150 mm cube. All the heights, width and depth all are the 150 mm, and basically this is the cube that was there. And how it is come? Actually, workability of concrete is required to know. Workability, by the name you can understand that workability of concrete means how much the concrete is workable. It is enough workable to the site, to the construction site or not, that will be checked out by some test, that is slump test, compacting factor test and VB consistometer. And after that all the tests done, then we are just mixing the cement, sand, coarse aggregates, and we prepare this cube. After at first we need to place all the manually mixed product with water, addition of water. We need to place it in a, first we need to just place some oils over there, because we need to lift it out again next day, and then we just place the mixture over here, and we need to keep it for 24 hours to harden the concrete. And after that we need to cure the concrete in a water tube, that may be a water bath, and we need to place the concrete over there for 7 days, for 14 days and for 28 days. Usually we prepare 3 cubes. Each time when we do the test, we generally prepare 3 cubes for 7 days, for 14 days and for 28 days. And we already prepared this cube before 7 days. Okay. And then after 7 days we are just doing the test, doing the crushing or compressive strength. Actually we need to test the strength of the concrete. To know the strength of the concrete, we need to crush the cube over here. And we prepare before 7 days the cube, already this is prepared, and for 14 days and for 28 days also the cubes are left over there for the water bath. And then for 7 days we need to test the cube, the crushing of concrete, and after knowing this we actually get the compressive strength of the concrete. We put the compression from both of the sides, and then we just put the cube over here.
So this is the CTM machine, compressive testing machine, which has a capacity, here it is written 2000 kilonewton. As we know, concrete is highly strong in compression, so we are basically focused on finding out the compressive strength of concrete. So this is 150 mm by 150 mm by 150 mm. It's a completely properly clean and uniformly made concrete of a certain grade of concrete mass, and we will insert this concrete cube in between these 2 base plates. So basically first is we are going to switching on this machine. This is the top plate which is fixed. This is the top plate which is fixed. This is the bottom plate which will move upward. It is a hydraulic based machine. So first we will, to insert this cube, we will lift down the hydraulic base plate. We will insert the cube. Now we will place the concrete cube in such a manner centrally in between these 2 plates. So if you see here, we are centrally placing this concrete cube strength, and coming to this dial gauge. This dial gauge shows the reading of the compressive strength. we are providing a compressive strength at a rate of 140 kg per centimeter square. Here we have the capacity of 2000 kilonewton and each division corresponds to 10 kilonewton. Here we have two needles, we have one red needle and the black needle. What happens when the crushing test starts and with the increase of the load, both the scale readings they start to move upwards. At one point of time, that is the time of failure of concrete, when the concrete cube completely crushes, then this black needle will fall down, while the red needle will be stagnant to a certain point of reading. So that is taken as the basic value of the compressive force applied on the concrete. So now we will start the compressive testing machine. Using hydraulic,
No gap will be there between the concrete cube and no gap will be there in between the concrete cube and the load.
so using this plunger, by hydraulic means we have contacted or we have kept the concrete cube completely in contact. The top surface is contact with the top plate which is fixed. The bottom surface is in contact with the bottom plate which is movable. Now we will slowly we will put the load. So this is the fine adjustment. This is the valve release of this is the lock where we can release the valve and close the valve, and this is the fine adjustment. That means by this either we can increase the rate of loading or we can decrease the rate of loading. So now we will start the procedure. Readings are increasing.
the crack is coming. Here the vertical crack is coming.
See, the crack is coming.
Already starting the crack here.
So outward bulging taking place. A rupture has started.
Already crack becomes prominent.
So the outwards, so crack has already started to initiate.
So see how the crack has been generated in the compacted concrete. So how, see
The outward edges have started to rupture. Crack have formation taking place.
how the crack takes place here after a great loading. Slowly and gradually all sides of the concrete becomes crushed under a certain load.
Now,
Okay,
now show the,
okay, now stop.
edge. It is
Now
become
Now we can
decreasing.
see
It is become decreasing.
the red mark is showing that it is the final value of load which is attained. Here we have got about 700 kilonewton. So it's a very good concrete mix. So we have got 700 kilonewton load which can be applied on this concrete mass. So now what we will do, if this is to calculate the compressive strength, it is also similar to compressive stress. So this load which we have got, we will divide it with the cross section area. So we have got 650 kilonewton. So 650 multiplied with 1000, that is in Newton.
700.
So 700 kilonewton multiplied with 1000, that will be Newton, and that we will divide by this cross section area, 150 mm multiplied with 150 mm. So the value of the stress which we get is the compressive strength of this concrete cube, which is also known as characteristic strength of concrete at the end of 28 days.
Okay, hence we get the compressive strength by the compressive force and divided by the area of the cube, that is 150 by 150, and we obtain 31.11. That means this is basically the target strength, and we know that the concrete grade of the concrete is M30, and the target strength we obtain nearly 31 Newton per millimeter square.
thank you.